In the 19th century, James Prescott Joule discovered the relationship between heat and mechanical work. He designed an experiment that consisted of a paddle wheel in water connected to a weight. The weight would then be thrown off to turn the paddle wheel, turning the water. The decrease in mechanical energy increased the temperature of the water, and from that he calculated the specific heat of water. Today, we're going to try to recreate James Joule's experiment.
Considering we don't have the time or the money, we're going to go by a much cheaper, simpler approach. We're going to use a cardboard tube that's actually gift wrapping paper, better insulated than a bare cardboard tube. And we're going to use zinc, which has a lower heat capacity than water, so we can observe a temperature difference in a much simpler testing environment. From this diagram, you can see we have our tube, we have our zinc in the bottom, and we're calling the average height of the zinc our initial starting point at 0. And when we flip this tube, right before the zinc falls, we have an increase in potential energy from the flip. This increase in potential energy will cause the zinc to eventually fall from the force of gravity, and this will essentially be the mechanical work that's converted into the thermal energy of the zinc, and this is assumed to cause a temperature increase.
Assuming that our system does not lose energy due to friction and that it is insulated, meaning that it's adiabatic, we can write the energy balance as such, where the potential energy times the number of flips is equal to the heat gained by the zinc. This system is actually independent of the mass of zinc, and we can calculate the specific heat.
So taking the average of CP, we get 0.735, and the percent error is about 88.5%.